from the single phase half wave rectifier circuit with two diodes that we have discussed earlier, we can arrive at some interesting conclusions which will be helpful to analyze circuits with multiple diodes. Let us look at the circuit that we have already discussed once again and see what we can understand. Here there are two diodes, D1 and D2, and their cathodes are connected together, and an AC voltage source is connected between the two anodes. That means there is a finite potential difference between the two anodes. This connection is known as common cathode connection, where the cathodes of two diodes are tied together and the anodes are at different potentials. This circuit can be rewritten as the circuit shown in right hand side. And what is K? K is the point where the two cathodes are connected together. It's a common cathode node. That is what we refer to as here. And IK is the current leaving the common cathode node. And as we have already discussed, this IK can be either positive or 0, because the diodes can only conduct in the positive direction. That means that the diodes can conduct current from only anode to cathode. So let us consider IK is greater than 0, that is the current leaving the common cathode node is greater than 0. Then in that case, if VAB, the voltage between the two anodes, if VAB is greater than 0, is positive, then we know that D1 is on and D2 is off. And when VAB is less than 0, that is negative, D1 is off and D2 is on. This VAB is the potential difference between the points A and B. It can be written as the difference of potentials of A and B with respect to a common reference point X. It can be any point. So VAB can be written as VAX minus VBX. So our conditions can be changed as VAX minus VBX if the potential of one anode, the anode A, is more than the potential of the anode B with respect to a common reference, then D1 is on, D2 is off. And when VAX is less than VBX, that means the potential of B is more than the potential of A with respect to a common reference point, then D2 is on, D1 is off. Or we can say that the diode with its anode connected to more positive potential is conducting in this case. Let us look at an alternate connection where the two anodes are connected together, and there is a potential difference between two cathodes, A and B. And the common anode node is denoted as N here. And current entering the common anode node is referred to as IN. And IN can again be only greater than 0. Why? Because the current can only flow from anode to cathode in a given diode. By the same analogy that we discussed earlier, we can come up with the conditions for different states of diodes in this circuit. So when VAB is greater than 0, of course we are considering the case where the current entering the common anode node N is positive. When the current is positive, that means the current is entering that node, and VAB is greater than 0, D4 is on and D3 is off. Both cannot be on at the same time for the reasons that we have already discussed. Both cannot be off as the current is positive. So the only possible state would be D4 being on and D3 being off. Similarly, when VAB is less than 0, D3 will be on and D4 will be off. Again, this potential difference between A and B can be written as the difference of potentials of points A and B with respect to a common node of reference, and let us assume that node of reference is X, then VAB is equal to VAX minus VBX. So when the potential of A is more than the potential of B, then D4 is on. That means the diode that is connected to B on the cathode side is on. And when the potential of A is less than the potential of B, then the diode connected to A at its cathode is on. That means in common anode connection, the diode having more negative potential at its cathode will be on. Let us try to extend this analysis to 3 diode case, the case of 3 diodes. Here we have 3 diodes D1, D2, D3 whose cathodes are connected together, and the common cathode node is referred to as K. Current leaving the cathode terminal K is denoted by IK, and from the previous analysis, if we consider 2 diodes in this connection, let us consider D1 and D2, when the potential of A is more than the potential of B, VAX is greater than BX, D1 is on, D2 is off. This is what we can say from our previous analysis. And now if we consider D1 and D3, if the potential of A is more than the potential of C, then again D1 is on, D3 is off. But we have all the 3 diodes connected together, so we also need to look at the relation between the potentials of B and C. So when A has the highest potential, there are 2 possibilities: VAX greater than VBX greater than VCX, or VAX greater than VCX which is greater than VBX. So in these 2 cases, it can be shown that D1 on and D2, D3 both being off is the only possible state. We can also verify this state by looking at the voltages across those diodes which are off. So VD2, if you look at VD2 is VB minus VA or VBA. If you apply KVL in this loop, when D1 is on, the voltage across D1 is 0. So K point is same as A point. So VD2 is VBA. And since VA is greater than VB, VAX is greater than VBX, VBA is definitely less than 0. So we assumed that D2 is off and its voltage turned out to be negative. So our assumption is correct. Similarly, if you look at VD3, since D1 is on, again K is same as A, voltage VD3 is equal to VCA. Since VAX is greater than VCX, VCA will turn out to be negative. So D3 being off is again a valid assumption. And how about D1 on? To validate that assumption, we need to look at the current flowing through D1 when it is on. Since the other 2 diodes are off, by KCL, ID1 is equal to IK. The current leaving the cathode K is same as the current flowing through diode D1. And since IK is greater than 0, it can only be greater than 0 or 0. It cannot be negative. So as long as IK is positive, the diode current is positive, so our assumption will be correct. By similar analysis, we can show that no other state is possible under these conditions. When B has the highest potential among the 3, like when Bx is greater than VBX is greater than VCX is greater than VAX, or VBX is greater than VAX which is greater than VCX, the diode that is connected to B at the anode, that is D2, will be on and the remaining 2 will be off. Similarly, when C has the highest potential among the 3, again the potential of the 3 is considered with respect to a common reference point X. When C has the highest potential among the 3, the diode connected to C at its anode will be on, that is D3. So in this common cathode connection of 3 diodes, there are only 4 possible states. What are those? Either one diode on or all of them are off. So one diode on means D1 can be on, or D2 can be on, or D3 can be on, of course the remaining being off. And when does that happen? D1 will be on when VAX is the most positive. So we need to compare the potentials of 3 anodes with respect to a common reference point. When A has the highest potential, D1 is on. When B has the highest potential, D2 is on. When C has the highest potential, D3 is on, as long as IK is greater than 0. If IK is equal to 0, that means the current leaving the common cathode node is 0, then of course all of them will be off. And IK cannot be negative because the diodes can only conduct in one direction. Similarly, we can arrive at the possible states in common anode connection of 3 diodes, where the 3 anode terminals are connected together and the cathodes are at different potentials. So here D4, D5, D6, there are 3 diodes which are connected in common anode connection, and N is the common anode node and IN is the current entering the common anode node. Again, the possible states are either of them being on or all of them being off. All of them will be off when the current entering the common anode node is 0, IN is equal to 0, but D4 will be on when VA has the lowest potential, or it is the most negative potential point, and D5 will be on when B has the lowest potential, D6 will be on when C has the most negative potential among the 3, and the potential is again with respect to a common reference point X. This analysis can be extended to any number of diodes, and here is a summary. When diodes are connected in common cathode connection, when multiple diodes are connected in common cathode connection, the diode with its anode at the most positive potential conducts, of course as long as the current leaving the cathode is greater than 0. And when the diodes are connected in common anode connection, the diode with its cathode at the most negative potential conducts. So these are 2 very important and useful conclusions which will be helpful in our analysis of diode circuits.